Okay, so we are going to actually do some solving now. So let's make sure that you're on page 5, and we are going to do example 1. Example 1 is solving equations by addition and subtraction. There are 4 examples that we will work on. I just want you to remember 2 key things and keep this in mind as you solve these one-step equations. This is kind of a review from last year. So you have 2 goals, really. The first is to isolate the variable. And what do I mean by that? I mean that you need to get the variable all by itself, all alone on one side of the equation. I like to say make the variable lonely. I know it's a sad, sad thing, but we want the variable lonely so we know the value of it. So when we solve an equation and we have the variable alone on one side, it tells us the value of that variable. So we'll have, I don't know, whatever the variable is. Let's say it's an x on one side, and the other side will be the value. So we'll say x equals and then some number, and we will know we have the value. We also need to make sure we use the properties correctly. And what that means is whatever you do to one side of an equation, you must do the same thing to the other side, whether that be addition or subtraction, whatever it is. Whatever I do to one side of an equation, I must always do to the other side. All right, so one other thing I wanted to show you. I linked the packets to you, and if you looked at your Google Classroom and it says packet for chapter 1, you'll notice that this line is blue. That is for a reason. If you clicked on that link in your Google Classroom of this packet, you would notice it will take you right to a video. The video is Big Ideas version of solving these or of showing you these examples. So after I do the video with you, you might want to actually use the Big Ideas video as well. And it does actually show you these 2 that we have here on this page. I'm going to take them one at a time, and we're going to start with 1A. So 1A and the steps that you need to follow for not only this particular equation, but any other equations going forward. So the first thing you want to do when you're solving an equation is you want to rewrite the equation. You don't have to actually put down this one rewrite, but you do want to take your pencil and rewrite x minus 7 equals negative 6. And why do we have you do that? Well, it actually creates more space, first of all. And secondly, it gets you to really read the equation before you start. It makes you kind of analyze what you're going to be doing in the equation. So rewriting it is always really, really helpful. All right, so step 2. Step 2 then is to undo the operation on one side of the equation and then again on the other side of the equation. Remember, my whole idea is to get that variable alone. So this is why we needed to actually learn the vocabulary here. This is my variable x. I want it all by itself on this side. But what is along with x on that side, the left-hand side of the equation, is a minus 7. In order to get x by itself, I need to do the inverse operation to taking away 7. I want 0 on this side. So when I take away 7, the inverse or the opposite of taking away 7 is to add 7. When I add 7 to this side, I need to make sure I add 7 to the other side. And that is doing the same thing to both sides, and it's keeping that balance. Remember, this is that balance scale. Once I take that away, I end up with x plus 0, because negative 7 and positive 7 combined make 0, equals 1. Do I have x all by itself on one side? Well, I sure do, because 0 really means nothing. So x equals 1. And this is actually my solution. I just found the value of what x must be in order to make this equation true. Now, the third step is probably the most important step. Step 1, rewrite. Step 2, undo the operation on to get the variable alone. So I want to undo the operation on the side with the variable. And the last thing I need to do is to check my answer. You need to check your solution each time. You'll always get an A, right? You'll have all your answers correct. But if you don't have it correct and you've written everything out like this, you can go back and find where you made your mistake. So let's look at, if I take the x out of this equation now and put the value of 1 in it, I end up with an equation 1 minus 7 equals negative 6. And if I solve the left-hand side of this equation, 1 minus 7 is negative 6 equals negative 6, I see that this is true. And because it's true, now I know this must be the solution for that equation. So this is how you would solve the first example. You should rewrite the equation, undo the operation, then solve for the variable, and check your answer. Make sure you write this down. I'm going to go on to the next example, so you can stop the video here and write this down. Example 1B. I'm going to actually use a pencil on this one so you can see me do it by hand. This is probably how yours is going to look. Mine will be really sloppy because I'm not really used to writing with a pencil but online, but I'll do it here for you. First thing I need to do is rewrite my equation. So I have 1, and you notice in this particular equation, I have my variable on the right-hand side. It doesn't really matter which side it's on, I still want to isolate it. So my equation is 1 equals W, my variable, plus 6, my constant. Okay? So now I want to get the variable alone. I need to undo the operation on the side with the variable. Well, the side with the variable is this side right here. So I need to undo the operation that's happening there. The operation that's happening here is addition. So the opposite of addition is subtraction. So if I subtract 6 from this side, that 6 will go away. I will have 0 on this side. But whatever I do to one side of the equation, I need to do to the other. So I will subtract 6 from this side of the equation. And when I do this, sometimes I even make a little wall here. You can if you want to, but the wall that I usually make it a different color so you can see what I'm talking about. It actually shows both sides of the equation. I also like to underline after I make my equation, or after I undo my operations, to see that I've done the next step. Now on this side, I have like a stacked addition problem. 1 plus a negative 6 gives me a negative 5. So on this side of the equation, I have negative 5. And over here, I have the W, my variable, and 6 minus 6 is 0. Do I have to add the plus 0 down here? No, I do not, because at this point, I have my solution. My variable is all by itself, and I have an answer for my variable. But I'm still not finished. I need to do step 3. We did this. Step 3, check my solution by substituting it in for the variable. So, okay, I'm going to rewrite my equation now. 1 equals, and instead of the W, I'm going to write negative 5, because that's the value I found for my variable, W. And I'm going to add the 6 just like it says in the original equation. Now I'm going to solve both sides. Well, on this side of the equation, on the left-hand side, I just have a 1. And on the right-hand side, I have negative 5 plus a positive 6. I have two different signs, which means I need to subtract the smaller absolute value from the larger. So 6 minus 5 is 1. And my largest absolute value is a positive 6, so my answer is positive 1. So this works because 1 equals 1. Last example. Stop the video if you need to so you can write all this down. Okay, you don't need to rewrite this part. Those are the steps. You can if you'd like, but I need to rewrite the equation. So right underneath it, I'm going to rewrite y plus 3.4, or 3 4/10. That's the way you actually say that number. 3.4 is usually the shortcut, but it is really 3 4/10 equals 5/10, 0.5. 5/10. Now I need to undo the operation on the side with the variable. This time it would be the left-hand side over here. What operation do I have happening? I have addition. So the opposite operation, or the undo for addition, is subtraction. So if I take the 3.4 away from this side, I need to do the same thing to the right-hand side of the equation. It's a little difficult, but I'm getting it done here. I'm going to make it look nicer. I'm going to make that part of my 3, and there's my negative sign. Okay, so here's my equation. I notice that I have my y by itself because 3.4 minus 3.4 actually makes 0. I'm just going to even cross it off. And equals, on this side now, I have 5 minus 3.4. Okay, so that means that, again, we need to use that rule of integers where I need to subtract the smaller absolute value from the larger one in order to find my solution. Okay, so I need to subtract this first. And I know I have to line up my decimal points in order to do that. So I'm going to borrow and subtract. 14 minus 5 is 9. 2 minus 0 is 2. The sign of my larger absolute value is negative, and my answer, I get negative 2.9. Okay? Now, am I done? No. I need to do step 3, check my solution. So I'm saying that y's value is, or y is equal to negative 2 and 9/10. So I'm going to put that negative 2.9 in my equation. And I'm going to add 3.4 to it. Ooh, 3s are really hard to make. And I'm going to say that those two together combined equal 5/10. Okay, so now I have opposite signs again, so I need to subtract. 3.4, largest absolute value, take away the smallest. Four, take away 9, I have to borrow. 14 minus 9 is 5, and 2 minus 2 is 0. The largest absolute value is a 3.4, so my answer is a positive 0.5, which is supposed to be. So it is correct. So I have my solution right here. Okay. So you need to write this equation in or try it on in your packet. If you want to stop the video here, you can. Okay, so this is the last video now. Let's do it in a different color. Let's do it in blue. How would you solve this? First of all, do you know what this symbol is? The symbol is actually, I love this symbol. This is the pi symbol, and everybody kind of makes them a little differently. Mine kind of looks like that. But pi is actually not really a variable. It's actually a symbol for a decimal that never repeats and never ends, and it's got a value around 3.14. It keeps going and going and going. It's really an irrational number, and we use pi a lot of times when we're talking about circles, but it is a valid math number. But and if you looked at a calculator, you would even see this symbol there. But instead of using this as a number, I'm going to just use it as the symbol itself, because it's really if this was the number 3.14 and this was the number 3.14, we could solve this, right? But we still can solve it with just the symbol, because this symbol represents this value. So I already know the value of the pi. I'm not going to solve it for the value of the pi. I'm just going to solve it for pi. So let's rewrite the equation first. This says r, which is our variable, take away 1 pi equals 1 pi. Seems simple, right? Remember, we have to undo the operation on the side with the variable. Well, we know that our variable is the r. So we're dealing with the symbol pi. And what operation is happening with the symbol of pi on the left-hand side of this equation, or the variable side of this equation? It's being subtracted. So in opposite operation, the undo operation for subtract is add. Okay, so I'm going to add a pi. A negative pi plus a positive pi makes a 0 pi, and it takes it away. But I know, because of that property, that whatever I do to one side, I have to do to the other. So I'm going to add a pi over here too, a positive pi. Okay, now I'm going to solve it. I have my variable r in the equation. Key is to isolate it. Negative pi plus a positive pi makes 0 pi's. They're gone. So I'm going to have r equaling, here's 1 pi, here's another pi, and if I have these to add together, I have 2 pi's. 2 pi's. Correct? All right. Let's make sure, though, we have to check our solution. So instead of the r, our variable, I'm going to substitute the 2 pi's in the equation. 2 pi's minus a pi. My pi's are getting wilder all the time. Equals a pi. Does it work? Let's see. If I have 2 pi's and I take 1 pi away, I am left with 1 pi. On this side of the equation, on the left-hand side. On the right-hand side, I have 1 pi. Do these two not equal one another? Does pi equal pi? Why, it sure does. So this has to be correct. You can stop the video. Well, you don't have to stop the video here. I'm going to stop the video.